All right, when we're talking about dropping things off a cliff, dropping things off a building, we know a couple things. Initial velocity, is it changing or constant? Okay, is it a number or a zero? Zero. Before I drop my pin, it is not accelerating. It's not going anywhere. It's still. My acceleration, is it changing or constant?
Constant.
Is it a number or is it zero? A number. In real life, it is 9.8 meters per second squared. From now on through the test, we're going to simplify that into 10 meters per second squared. Notice I am not writing that negative. Negative is talking about direction. What about VF? Is final velocity changing or constant? It's changing. At every second, it's going to be something different. Is it a number or zero? Number. All right. So we're going to assume that gravity is negative 10 meters per second squared for this problem. However, we are going to be solving for time, which means we don't need a direction. Time does not have a direction. We don't say, hey, dinner's at -8. We say dinner's at 8 o'clock, right? So we have a distance of 125 meters. We have an acceleration of 10 meters per second. We have a VI of what? 0. So I'm going to use my distance formula, which is distance equals VI times time plus 1/2 AT squared. And I'm going to plug in what I know. I know that 0 times time is 0. It goes away. I'm left with 125 equals 5t squared. I have to divide both sides by 5. So t squared is equal to 25. I'm not looking for t squared. I'm looking for time. So I'm going to square root each side. Time is equal to 5 seconds. So for that rock, it takes 5 minutes or 5 seconds before it hits the ground. Now I want you to fill in the chart below. We have different times, 1, 2, 3, 4, and 5. We're going to use our formulas. A equals VF minus VI over time.
Do you use this paper on the test?
No, but you can put everything on this paper in your note card.
So I can.
Besides, this is only half the test. You still have to do the toss-up. All right, at 1 second, what is my final velocity? My acceleration is 10 equals my final, what I'm looking for, minus 0 over 1.
10.
Yes. Now, I can either say 10 meters per second down because velocity has direction, or I can remember to use my negative with my acceleration and make it negative, which tells me what direction it's going down. Keep in mind, guys, all I'm doing is cross multiplying. I'm putting this negative 10 over 1, cross multiplying, VF equals, for instance, negative 10 times 4, which would be negative 40. You're expected to be able to do this on your own. It is a skill that you need to make sure you have. Just off of the distance, I'm going to use my distance formula. The distance equals 1/2 times time plus 1/2 AT squared. I'm going to plug and chug it. Basically, I'm going to plug in everything I know and solve it. So this simplifies down to 1/2 times 5 times 1 squared. Oops, 1/2 times 10. Sorry, I did math in my head. Give you 5 meters. Again, you can either know that it's 5 meters down, or when you use your 10, you can add that negative sign.
They don't have to put the zero, right?
No. I'm going to be honest with you, at this point, if you're not bored because you can do this very easily, I'm worried for you on that test. My acceleration due to gravity, because we're using simplified math, is 10. Does that change?
No.
Okay, draw a conclusion. For a dropped object, final velocity, what do we notice? Is it just randomly going up?
No, it's going up by 10.
It's going up by 10 meters per second, right? So it is going up at a constant rate. And my acceleration stays constant. I've looked over some quizzes. It seems like y'all get a little flustered, you get a little bit, and you put things like that you have a change in velocity or change in acceleration. So I need you to be careful about on the test. Take your time, read it. I'm gonna try really hard to get a really good stopwatch going up there so that you know how much time you have left. Yes.
Like one of the quizzes, I know I have a time limit, so I'm gonna take some real fast.
Yeah, I know. That's kind of the point, but you also have a time limit on the test because I can't stay here till 6 every night. I get cranky. All right. The last thing I want you to write, and I want you to write the whole thing because it's important, is what conclusion can you make about the distance? What's it doing? It is increasing. Is it a steady rate?
Yes.
No.
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 Oh, no.
That's fine.
It actually increases at an exponential rate.
Exponential.
Exponential.
That's when it's not constant. What
It's
does that even mean?
that's squared. It's going up. So if you plug in an exponential equation on your calculator, you'll see how it's moving.